Schoology every single grade, and that's the story of the evolution of Wade.
All right, this is lesson 1-3 for AB Calculus, and we continue our discussion about the chain rule. You remember that was important last time. So there's something we haven't talked about yet, and that is trigonometry. Trigonometric derivatives. Yes, sine, cosine, and tangent, all three have derivatives because they all have graphs, and every graph has a steepness, and the steepness is actually measured by the derivative. We haven't talked about that a lot in AB yet, of course, but I got a brand new thing for you today. So first question is, how do you take the derivative of sine of x cubed plus 1? So let's write down y prime equals. Okay, so the derivative of sine, it's been proven in calculus long ago in the 1600s that the derivative of sine is cosine. Now just wait till we get to all the real life problems eventually, and you'll see what all these derivatives mean. But first you have to master how to take a derivative. What have we always been saying so far about the base, the inside? The base always stays the same, right? Have you noticed that so far? Same thing today. Derivative of sine is cosine of the quantity x cubed plus 1. All right, but that's not it. Times something else. Sine becomes cosine, base stays the same, times every derivative has a chain rule. We've been talking about this, right? You must have a chain rule. What's the chain rule? The derivative of the original base. So go back to the original base. We kept it the same like we're supposed to in derivatives, but we never did run it through the derivative process. X cubed plus 1 eventually has to go through the derivative process. The time is now. The chain rule. Okay, what's the derivative of x cubed plus 1 like it's a brand new problem? The derivative of x cubed is 3. X stays the same. Drop the power by 1 to the squared, right? To the second. 3 to the front, x drops to the squared. What's the derivative of plus 1 or any constant? 0. Hopefully you're getting the hang of this now. That's 0. Okay, so the chain rule is just 3x squared. It's a single term, it's a monomial. I didn't even have to put parentheses, really. Now, is that the final answer? Yes, it is. There's no sense in taking this term and distributing it. And by the way, it is impossible mathematically to distribute this into there because this base is locked into the cosine, okay? There are several things that are locked that I call superglue in calculus. Sine, cosine, tangent, all three of those. Also, eventually we'll talk about the other ones from pre-cal. You remember cosecant, secant, cotangent. So anything trig is locked into the parentheses. And also log and natural log are locked to the parentheses. All those things. And that's it, just those things. Okay? So when you say cosine of this, the of is the superglue. So since it's locked, you will never ever be able to distribute this into there. That would make no sense at all. That's impossible. Now, if you circle that, that's fine. I would rather do what they do in college. I would rather put the 3x squared as your coefficient in front of the cosine. Not a huge deal at all, but that just looks better. So the trig function is supposed to come last. And this is actually more acceptable in college, okay? But even the previous step is full credit, that's fine. All right, letter B, you will encounter things like this in calculus. 3, so it has a coefficient this time. Cosine of whatever they want to put in the parentheses. They can put anything in there. All right. Y prime equals. If you want to, let's do this. Later you'll be able to do this without even hardly showing any work because you'll be so good at these things. But for now, if you want to write this radical form, remember we're supposed to go to exponent form. So square root of x is x to the what? Square root of x is x to the first power secretly and second root secretly. First power over second root. Remember, square roots are always to the 1/2 power, okay? So that's probably a better form there. Now, when you take the derivative, there's no power to the front, subtract 1 from the power yet. You notice this is a little different today. This is not a polynomial, so we're not bringing powers down. The derivative of sine was cosine, right? The derivative of cosine is negative sine. So y prime equals. So the derivative of cosine is negative sine. And the negative goes on the 3, always goes on the coefficient. And now I think we maybe haven't emphasized this yet in AB class, but when you have a coefficient, this could be the first time we've had this. When you have a coefficient, the coefficient just stays. The coefficient is just 3 times as much as it would have been without the 3, okay? So you keep your coefficients, and you're going to memorize that the derivative of cosine shall be sine. What about the base? Base stays the same, always in derivatives, right? But then there's something else. Derivative of cosine is negative sine. What about the chain rule? Every derivative has a chain rule. The derivative of the original base. So go back to your original base, and that was x to the 1/2. What's the derivative of x to the 1/2? Because that's going to be your chain rule right here. The derivative of x to a power is power to the front. Base stays the same, so x. Subtract 1 from the power. We'll put that off to the side. 1/2 minus 1. What is 1/2 minus 1? 1/2 minus 2 out of 2 is the same thing as 1 whole, right? So 1/2 minus 2 over 2. 1 minus 2 is negative 1. Common denominator is 2. All right, and that is your chain rule right there. And there's your derivative. We just need to clean it up a little bit, of course. So y prime equals negative 3 sine of. Okay, x to the 1/2. X to the 1/2 should go back to radical form where it came from. Wasn't x to the 1/2 just square root of x? Okay. This we need to fix because you can't leave negative powers, right? So let's think about who is where. Here. 1's on the top, 2's on the bottom, x is on the side, which means top. So really the x is up there with the 1, isn't it? What does the negative power tell it to do? Take the x, move it from the 1 upstairs to the 2 downstairs. Okay, so let's draw a fraction bar. So the 1 stays up there, the 2 stays on the bottom, and the x to the negative 1/2, which is technically side, which is top, gets moved to the bottom, where it is no longer x to the negative 1/2, but now x to the positive 1/2. All right, and that's how you fix that. Okay, I would take that answer. Better to put this back into radical form, I would say. And here's another thing too. So that this is an okay answer here. Isn't everything in math secretly over 1, basically? If it's not already a fraction, right? That whole thing is over 1. That whole thing is in the numerator being multiplied by 1. Why would you even keep the 1? Anything times 1 is itself. Same thing on the bottom. 1 times this is this. So like the 1's don't even need to be there. So really for your best answer, here's what I would prefer from our top students. And if you're in calculus, you're already a top student. I mean, come on. So the numerator is negative 3 sine of square root of x. We drop the 1, no need for that. And then the denominator, no need for that 1. Just put 2x to the 1/2, or even better, 2 square root of x. Isn't square root of x the same thing as x to the 1/2? Okay? And that's a great answer right there. And if you remember mention in integrated 3 and pre-calculus both of you're not supposed to have square roots on the bottom in math, right? That's a big deal that people talk about. I got a little secret for you if you've never heard this before. The square root of a number like square root of 3 is not supposed to be on the bottom. But the square root of a variable, you must leave it on the bottom. Because if you try to get rid of the square root and do some of that stuff from pre-calculus, it's really just going to cause a disaster and make this thing look way worse. So square root of a variable should stay on the bottom. That's fine. Okay? Square root of a number should not. All right, so for letter C, we've got a coefficient, -8. We've got tangent. So we did sine, we did cosine. Of course, tangent has a derivative as well, right? And then you have some arbitrary base that they could make whatever they want to make it, okay? No problem. Y prime equals, okay, as I mentioned in the last problem, this is kind of new to AB. The coefficients just stay. The coefficients don't really do anything. It's just -8 times as much as it would have been if you hadn't had the -8 there. So you just let the coefficient stay, okay? Tangent, the rule for tangent. So derivative of sine is cosine. Derivative of cosine is negative sine. And the derivative of tangent is secant squared. Interesting. And the base always stays the same, remember? Base always stays the same, times. Okay, don't forget something else here. So you're going to memorize that tangent goes to secant squared when you do the derivative, and then eventually we'll do all the real life stuff that derivatives measure. Okay? And if you remember from pre-calculus, what's secant? Just a little side note here. Secant of x or secant of theta, remember the thetas? Secant is 1 over cosine by definition. So secant squared is just 1 over cosine squared from pre-calculus, okay? That's all that means. You actually will not change this into 1 over cosine squared. You don't need to, all right? That's just, I want you to remember what it is. And every once in a while, we'll go to this definition from pre-cal, but usually we won't, okay? So the last thing we need to do is multiply by the chain rule, right? Let's try it. All right, do not forget the chain rule in the first test because every derivative has a chain rule. All right, so tangent went to secant squared. We kept the coefficient the same. We kept the base the same, as always. And then you go back and say, original base, I never did take your derivative. You got to have the derivative taken at some point. So here's my chain rule down here. What's the derivative of 3? Constants become 0, or you don't even have to put it. What's the derivative of -11x? Okay, again, remember our discussion. Let's go back to like a basic. Let's go back to 2x. Remember the derivative of 2x to the first secretly? Doesn't the 1 come down? 1 times 2 is 2. Doesn't the base x stay, but doesn't the power drop by 1? And isn't anything to the 0 just 1? Times 2 is 2. Okay? And I want you to remember this. We go over this frequently until you feel really comfortable. The derivative of 3x is just 3 by the same method. The derivative of 4x is just 4. The derivative of 108x is just 108. Okay? All the ones with just x to the first are so easy. So the derivative of, let's call that negative instead of subtraction because it really is. Negative 11x, the derivative is negative 11 without the x. Okay? There's your chain rule. And now we simplify. Pretty good answer right here. Let's make it really nice though. Y prime equals, okay, final answer. -8, and we can drop the 0 because 0 minus 11 is just -11. you've got negative 8 times the secant squared of all this times negative 11. It's all multiplication. When you have a single term times a single term, you must join those together. You don't leave negative 8 times negative 11 in a math problem, because we all know what negative 8 times negative 11 is, right? Negative times a negative is a positive, and 8 times 11 is 88. That's your coefficient. You know what I'm doing? I'm taking the negative 11 and moving it up to the coefficient and then combining it with the 8 by multiplication. Okay? So if you have a couple of single terms, you want to put those together. All right? 88 secant squared of 3 minus 11x. It's trig, it's superglued, so you can't ever distribute into this parentheses because it's locked. Somebody locked the gate and then they like superglued it shut. You ain't getting in there. Okay? There's your answer to secant squared coming from tangent. All right, letter D is going to be a challenging one. Now, the first three we just did, practically no student misses those on the first test. They're just too easy. Okay, just memorize the rules. Now, this one's a little bit more intuitive. Y equals sine of tangent of 7x squared. Now, you don't see that in pre-cal, sine of tangent. Only in calculus would you see something this crazy. So this is a more challenging one. Letter D, I would consider one of the few test 1 questions that is at the challenging level, and some of you are going to get it, some of you won't. Let's try to get as many people as we can to get this right, okay? So one of the few that is at the top level. You know, it's kind of like back in the old days in integrated 3 when Mr. Ray would, remember I would stand at my podium and I would say,
"Now students, you're all in an honors class. I know what you're thinking. Mr. Wade, challenge us. Challenge us. Challenge us."
oh right, the good old days, right? Yeah, before the pandemic, back when life was normal. Anyway, so y prime, the derivative of sine. Just forget about this interior, this base of tangent of 7x squared right now. You're still taking a sine derivative. We just said in letter A today that the derivative of sine shall be cosine. So sine becomes cosine, and the base always stays the same. Okay? But wait a minute, what did we learn today? Times the chain rule, the derivative of the original base. Anything that stays the same, which it should, must eventually be run through the derivative process. You have to eventually address it, and the time is now. We have to find the derivative of tangent. As a matter of fact, let's do that on the sideboard. So we'll do something that we call an aside. I believe we use that terminology occasionally in integrated 3. They use it in college as well. Okay, so off to the side, we're going to focus on base equals tangent of 7x squared, and we're going to find its derivative. Base prime, we'll call it. How about that for a slang? All right, what is the derivative of tangent of 7x squared? Because that's my original base, and I need the chain rule of it to be inserted right here. Its derivative. Okay, now according to the conversation today, the derivative of tangent is secant squared. All right? And then what about its little base, 7x squared? Yeah, its base stays the same. That always happens. And here's the part that students forget. There's a second chain rule. This problem has a double chain. Anything that stays the same, which is always the base, must eventually be addressed. You have to run 7x squared through the derivative process. What's the derivative of 7x squared? Bring the 2 down. 2 times 7 is 14, x to the first. That goes at the end. So what is the real tangent rule? The derivative of tangent is secant squared of the same base times every derivative in the world has the chain rule of the original base. All right? And students will forget that last chain rule, or sometimes they'll forget this one and they'll only put this one. That happens too. You got to get them both in there. All right, that is our chain rule. It gets inserted back here. I didn't make these parentheses nearly wide enough, but secant squared of 7x squared times 14x. So we insert that right back in, okay? That is the derivative of the original base, with the double chain this time. Okay, I mean, you're pretty much done right there. I guess if you could do anything, cosine of something, that's trig. Secant squared of something, that's trig. 14x, that's a polynomial. That actually should be your coefficient. So, not that I would count off, but I would probably put the 14x up as the coefficient in front. Then put the cosine of tangent of 7x squared. And then finally put secant squared of 7x squared. And that's about all you can do with that one. Okay? The trick is the double chain. All right, so I want you to try the homework. See if you can even get the one right with the double chain. That should be letter D. And then we will convene in class and we will talk about it and see how you did. What did we do? We did that, and my script is right here. We did that in problem A. We did the derivative of all right, let's take our, where am I even looking? I went back in the class mode. I was like, all right, oh, there's nobody here. I need to be looking at the camera. I just realized that after I did the flashback scene in a blue shirt and then I came back, I forgot to change back into the green shirt. Did anybody else notice that? Total disaster. Well, I tried to entertain you.